I forgot to unmute myself. My Quest. All right, now you can hear everything. Yeah, I have a complicated setup. I'm using, wait a minute, let me put this away. Yep, cool. I'm using Quest 3 as my virtual monitor, so I can have 3 gigantic monitors on the Quest. And one of those runs OBS, one of those runs my stream manager on Twitch, and the other one is my main, this is my working monitor. Let's see, I don't think I changed anything. Yep. Let me have a recap. Going to Xcode. I think last time we were working on making the initializer a async initializer, so we could call the load state. If we don't, what would happen? Actor isolated instance method in a synchronous non-isolated context. I forgot why it was saying this, but we did ask the ChatGPT. Let's see. I was working with ChatGPT to name the stream. Yep, this exact problem. And give me 1 sec. Let me read some messages. Oh, good. Let's come back to this. I think I want myself to speak a bit more softer because I was sort of speaking too loudly and my throat, my voice couldn't really take it. So the error was load state is a method that is actor isolated. It can only be called from inside the actor's own execution context, and it's implicitly asynchronous. Okay. I don't like how this is implicitly async. Let's see, if we do go to, let's see. I don't know why, but sometimes if I double click my controllers on the Quest, well, the Quest controllers. Okay. Yeah, there was a bit delay. All right. Let's see. I can't really call that method here because it is a private method. But if I go back here, and let's say if I change this to public, if I can spell public. Yeah, if we go into the spec, and if we say controller dot load state, it is async. Okay, but what about controller, any other method? Everything is async. Interesting. Didn't know this beforehand. Okay, so I still want to change this to a private func. So it's a load state. Okay, right. So every method in the actor is async, but implicit. I really should get used to using the transcribe with ChatGPT. Exactly, every instance method on an actor is actor isolated, which means that even if you don't write async in signature, the compiler treats it as if it were async whenever it calls. Okay, inside the actor's own code, for example, from another actor isolated method, you can call load state directly without a wait. Outside the actor, even the initializer is like outside the actor. Every call into the actor must go through the actor's gate, which is asynchronous, or wrap it in a task as shown before. Okay, I see. Let me see. Swiftly actor. Yeah. Swift actors are new in Swift 5.5. Yep, blah, blah, blah. Inspired by the actor model, treats actors as the universal primitives. Let's see. Of concurrent computation. However, proposal introduces, why does it say however, and explain which problem they solve. Data races. When the same happens when the same memory is accessed from multiple threads without synchronization, and at least one access is a write. Yep, that we know. Actors protect their state from data races, and using them allows the compiler to give us helpful feedback while writing applications. In addition, the Swift compiler can statically enforce the limitations that come with actors and prevents concurrent access to mutable data. They are reference type, but different compared to classes. Okay. Why is that? They're basically like classes, so the copies refer to the same piece of data. Yep. Therefore, modifying the copy will also modify the original instance, for sure. They do not support inheritance. That is pretty good. I like how it is. There's no overriding, there's no open or final or other stuff. Okay. Is isolating access to data. How actors prevent data. Let's see. This is like a deep dive into what actors mean. I have a rough understanding of it, but I want to check my understanding by reading someone else's knowledge. Prevent data races with synchronization, creating synchronized access to its isolated data. Okay. Using all kinds of locks before the actors, for sure. So this is how we use how we used to create synchronized access with locks. Sure. There is a lot of boilerplate, for sure. Now with actor, the compiler does all the locking for us, and it hides away all that implementation detail of the locking. Actor isolated instance method chicken starts eating can only be referenced from inside the actor. Yeah, this is where we need to add a wait. I see. Oh, the static one, you can access it directly, but if it is a var or it is a method, then you have to do await. In the above example, we're accessing two distinct parts of our actor. Firstly, we update the number of eating chickens, which we perform another, after which we perform another asynchronous task to print out the number of eating chickens. Each await can result in a suspension of your code to wait for access. In this case, having two suspensions makes sense, as both parts don't really have anything in common. However, you need to take into account that there could be another thread waiting to call chicken starts eating, which might result in two eating chickens at the same time we print out the result. To understand the concept better, let's look into a case in which you want to combine operations in a single method to prevent extra suspensions. Imagine having a notifier method. Okay. Mm-hmm. Interesting. Non-isolated access with the actors. It's important to understand the concept of isolation with actors. The above examples already show how access is synchronized from outside actor instances by requiring the use of wait. However, if you watch closely, you might have noticed that our notify observers method didn't require to use a wait for accessing our mutable property number of eating chickens. Yep. That's basically like, if you want to call this, that's basically what ChatGPT told me. If you're calling this inside the actor, when accessing an isolated method within actors, you are basically allowed to access any other properties or methods that would require synchronization access. That is pretty cool. There are cases, however, where you know that it's not required to have isolated access. Methods in actors are isolated by default. The following method only accesses our immutable property, food, but still requires a way to access it. I see. This is odd, as we know we don't access anything requiring synchronized access, and SE0313 was introduced to solve exactly this problem. We can mark our method with the non-isolated keyword to tell the Swift compiler our method is not accessing any isolated data. I see. Note that you can use the non-isolated keyword for computed properties as well, which is helpful to conform to protocols like custom string convertible. I see. But data races can still occur when using actors. Interesting. For example, imagine two threads accessing our actor's data correctly using await. The race condition here is defined as which thread is going to be the first to start isolated access. Uh-huh. Let's see. Whether Q1 or Q2 runs first. That is pretty cool. There are so many things to read about the new concurrency stuff. It's very fascinating. This came out recently. Wait, even I am on Swift 6.1.2, and this is already using Xcode 26 beta. Yeah. So this is even more into the future. Yeah, it's not as approachable as it can be, right? Okay, what are they doing then? Simple single-thread code. By default, your code runs sequentially. No parallelism, no data races, just straightforward execution. Ah, that's quite cool. Write async code without data race safety errors. Using async away lets you suspend execution without introducing parallelism. Just clean async workflows, boost performance with parallelism. Offload work from the main actor, use structured concurrency, and let Swift's compiler. Okay. Phase 1, no concurrency at all. Phase 2, suspend execution without parallelism. Phase 3, advanced concurrency. Uh-huh. How are they gonna improve it? Automatic migration using a so-called migration build to accommodate these changes more easily. Okay. How do we filter? So version 6.2, isolated synchronous D-neat. Run non-isolated async functions on the caller's actor by default. What does this mean? Control default actor isolation inference. Global actor isolated conformance. Main actor, all the things, really. What is the main actor? Yeah, let's see. What is the main actor? If you were to write a comment for myself. Oops. I didn't mean to show that. Wait, let me have a look. What was shown? General curiosity, the clinic, language rated. Okay, nothing too much. That's a big note. Love it. Change it to comments rather than doc strings. Note, all instance methods of this actor are actor isolated. Which means any call from outside to this actor is implicitly async. All right, let's see. And let's see, if I send out a pinned message, I don't like how in OBS you can't really just paste a thing. I'm under the weather with a sore throat today, so my voice is gonna be a bit weak. Thanks for understanding. Yeah. I'm calling from outside, including init, including sync. Init, you must mark your contact async and write await or wrap it in task. Interesting. And yeah, let's come back here. Add a part about using non-isolated keyword. Actually, this is a pretty good like a documentation. That is not true. Anyhow, that's just my learnings. I don't think it has to be here. Let's come back to these. Async function isolation. It's implemented in Swift 2.6.2. Swift's general philosophy is to prioritize safety and the ease of use over performance, while still providing tools to write more efficient code. The current behavior of non-isolated async functions prioritizes main actor responsiveness at the expense of usability. This proposal changes the behavior of non-isolated async functions to run on the caller's actor by default, and introduces an explicit way to state that an async function always switches off of an actor to run. What does it mean? Clarify the execution of non-actor isolated async functions. Specify non-isolated async functions never run on an actor's executor. This design decision was made to prevent unnecessary serialization and contention for the actor by switching off the actor to run the non-isolated async function. And any new tasks it creates that inherit in isolation, the actor is then free to make forward progress on other work. This behavior is especially important for preventing unexpected overhead on the main actor. Wait a minute. So you are saying I'm spending so much time to understand all this, now you guys are making improvements or making changes to this in 6.2. Non-isolated is difficult to understand. Yeah, that's right. There is a semantic difference between the isolation behavior of non-isolated synchronous and asynchronous functions. Non-isolated synchronous functions always run on the caller's actor. While non-isolated async functions always switches off of the caller's actor. This means sendable checking applies to arguments and results of non-isolated async functions, but not non-isolated synchronous functions. I feel like this is human speaking computer language. Why can't they just write something that's more humanly understandable? Let's see. Can ChatGPT make sense of this? Reading a Swift proposal, and this piece of text is hard to understand. Rewrite it in a more human readable way. I feel like these people, they might be really like familiar with how a compiler works, but it's just like the Xcode message we read a while ago. It's hard to understand. The keyword behaves differently depending on whether the function is synchronous or asynchronous. Okay? Non-isolated synchronous functions always execute immediately on whatever actor or thread called them, so they don't switch context. This is easy to understand. Non-isolated async functions, on the other hand, always hop off the caller's actor before they run. I see. See, this is much easier to read. Gosh, why do we make our life so hard? Mm-hmm. Mm-hmm. I think I can understand it when I read it, but here's the thing. A lot of this stuff, once you don't read it, or once you are like not familiar with it anymore, it just catches you. I really like the sort of earlier days of Swift where the code is easy to understand, the compiler is also sort of easy to understand. Like Swift 2, 3, maybe 4, things are easy to understand and you know what you're doing. With 5 and 6, I mean, they're trying to make it safer. I understand that bit. I understand it's a hard thing to achieve with the tools that we have right now. But my problem with it is it just made things much more harder to grasp and have a very concrete understanding in your head all the time. Unless, I mean, you're working with it all the time, for sure. Does that make sense? Anywho, let's get back to this. Async functions that run on the caller's actor are difficult to express. It's possible to write an async function that does not leave an actor to run using isolated parameters and the hashtag isolation macro as a default argument. Huh? Perform async isolation isolated any actor equals isolation. Huh? This resolves the data rate safety error because perform async now runs on the actor. However, this isn't an obvious solution. It's onerous boilerplate to write, yeah, and the default argument is lost if the method is used in a higher order manner, yeah. It's easy to write invalid async APIs if the perform async method were in a library that programmer doesn't own. It's not possible to work around the data rate safety error without using unsafe opt-outs. It's common for library authors to mistakenly vend an API like this because data rate safety error only manifests when calling the API from an actor. Oh, wow. Wow. Even the concurrency library itself has made this mistake, and many of the async APIs in the concurrency library have since transitioned to inheriting the isolation of the caller using isolated parameters. Oh my god, C0421. It's difficult to write higher order async APIs. Consider the following async API, which provide a with style method for acquiring a resource and performing a scoped operation. Gosh. Getting a resource, getting a result on the resource, waiting for the resource to close, and then returning the result. Despite with resource explicitly running on the caller's actor by default, there's no way to specify that the async body function value should also run in the same context. Yep. Let me have a little bit more water. This is so much reading. So what do we propose to do? This proposal changes the execution semantics of non-isolated async functions to always run on the caller's actor by default. This means that non-isolated functions will have consistent execution semantics by default, regardless of whether the function is synchronous or asynchronous. So if you have an actor and X is not sendable and you have async call, you can call x.perform async, that is okay. And you can await x.perform async, that is also okay. See, now I have got why it wasn't okay before. The call leaves the actor to run the function. This frees up the actor to run other tasks, but those tasks can access the non-sendable value X concurrently with a call to perform async, which risks a data race. Yeah. Headaches. Oof. A new non-sending, non-isolated non-sending can be written. Okay, changing the default execution semantics of async can change the behavior of existing code. Yep, so the change is gated behind the non-isolated, non-sending by default upcoming feature flag. Oh god. To help stage in the new behavior, new syntax can be used to explicitly specify the execution semantics of an async function in any language mode. Why do they have to make this so hard? Why? And you cannot avoid this async stuff. Like at the very beginning, I was trying to write things the not async way, just with a class. But then we ran into the issue where the compiler is complaining about, hey, do you know this could cause data races? A new non-sending argument can be written with non-isolated to indicate that by default, the argument and result values are not sent over an isolation boundary when the function is called. The add concurrent attribute is an explicit spelling of the behavior for the behavior of async function in language modes less than 3.6. Concurrent indicates that calling the function always switches off of an actor to run. So the function will run concurrently with other tasks on the caller's actor. Oh my god. Here's the thing, the whole thing keeps evolving, so you have to know what version of Swift you are using, and if you are working in a company, say they can't upgrade to 3.6.2 yet, but you want this new sort of modes or whatnot, oh gosh, it's a headache. Managing different versions. Control default actor isolation reference. This proposal introduces a new compiler setting, okay, for inferring main actor isolation by default within the module to mitigate false positive data race safety errors in sequential code. Mm-hmm. Mm-hmm. How come it took them so long to realize? Yeah, exactly, to avoid annoying programmers with unnecessary diagnostics and to reinforce progressive disclosure. Make it approachable, yes. The easiest and best way to model single-threaded code is with a global actor. Everything on global actor runs sequentially, and code that isn't isolated to that actor can't access the data that is. All programs start running on the global actor, main actor. And if everything in the program is isolated to the main actor, there shouldn't be any concurrency errors. Yep. Ah, gosh. Yeah, writing a single-threaded program is surprisingly difficult under the Swift 6 language mode. That is because Swift 6 defaults to a presumption of concurrency. Oh, everything is concurrent. If a function or type is not annotated or inferred to be isolated, it is treated to be non-isolated, meaning it can be used concurrently. This default often leads to conflicts with single-threaded code, producing false positive diagnostics in cases such as global and static variables, conformance of main actor isolated types to non-isolated protocols, class deinitializers, overrides of non-isolated superclass methods in a main actor isolated subclass, and calls to main actor isolated functions from the platform SDK. So here, everything is a main actor. Main actor, global actor, non-isolated, non-isolated, non-isolated. Shoot. They are just making this complicated. I feel like this reminds me. Do you know what this reminds me? This reminds me of like when Swift introduced protocol or interface. And then everyone just wrote everything as an interface or protocol because that's the cool thing. And then it took a while and people realized that, hey, not everything has to be a protocol, especially when there's only one thing that conforms to that. It's not Java. Nothing wrong with Java. Generalize effect polymorphism for async sequence and async iterator protocol. I am not gonna read this anymore. My brain's tired. And the thing is, it's hard. It's hard to make sense of all of this, especially if I haven't done much of the Swift 6 concurrency things. And now they're talking about, we're going to fix Swift 6 concurrency things with all these new parameters. If you turn this on, it will behave this way. If you don't turn it on, it will behave the way before, which was bad. But if you turn it on, you have to change your code. Shaking heads. Shaking heads. Running non-isolated async function on the caller's actor by default. Yep. So this one would go like, because it is async, it will be like, oh, I'm running in different threads now. That is a workaround. But I'm surprised that works, because you're basically just returning the same thing, and the compiler is like, I don't like you doing that, but doing this, that is okay. That is pretty cool. Swift concurrency is getting improved in Swift 6.2 to make it more approachable. This will impact existing projects positively too, but it will require some additional changes like several opt-ins. Eventually, it should be easier to adopt Swift 6. And the newcomers to the language will likely get exposed to Swift concurrency at a later stage. It's an exciting time as a Swift developer, and it's never been a better time to start investing in your concurrency knowledge. Start writing efficient, thread-safe code and adopt Swift concurrency using my Delegate course. Is it really an exciting time to be a Swift developer if you have to juggle different behaviors between different versions of Swift and knowing what flags turn on, especially if you're just writing a Swift package? It's not. It's never been a better time to start investing. Maybe. No, that's just the advertisement for your course. Thank you very much. I don't think I want it. Default actor in Swift 6.2. Isn't that you need to turn on a flag? Didn't we just talk about this? Default actor isolation. Non-isolated or the main actor. While new projects already use the main actor as their default isolation, existing project needs to opt in explicitly. That's a compiler setting in Xcode project. But what if you're writing a SDK? Yeah, there we go. Default isolation main actor.self. Oh, Interesting. But that's only available to 6.2, right? Okay. Migrating to Swift 6 introduced a lot of stricter rules around concurrency. Without default actor isolation, the compiler assumes that your code is non-isolated, allowing access from any thread. This often leads to a flood of warnings and errors when working with code that interacts with the UI or performs other main thread only work. I'm sure many of you have been adding main actor in many places, only to find out more warnings and errors will show up after compilation. By enabling main actor as default, Swift helps reduce the noise. A lot of your existing code, especially UI code, already assume it's running on the main thread. With the default isolation in place, the compiler aligns with that assumption, so you don't have to mark every method or property with main actor explicitly. So should I wait for migrating until Xcode 26? In my opinion, yes, even more so since the Swift team is currently working on migration solutions. These migrations will impact changing to concurrent, to add concurrent, as well as other Swift 6.2. Okay. My question, there is a Xcode releases.com website. I am curious. Oh, wait. Why do I have 6.1.2? 17A524, yeah. Oh, so that one. We should have Swift 6.2. Swift version. Oh, it is Swift 6.2. I see. I thought it's 6.1.2 for some reason. Alright, I've been streaming for like 15 minutes. I am gonna take a break and I'll be back shortly. Let's see. Mhm. Okie dokie, we are back. Wait a minute. Oh, why can't I not hear myself? I know, that's because I haven't put on my monitoring things. When I say things, I mean to my monitoring headphones. I'm also waiting for my lunch to arrive in a bit, but I do want to find out a bit more about Swift 6.2. Let's say Swift 6.2. Yeah, that one. And this one. Let's see. Swift 6.2 is the upcoming, yep. Improving the approachability of data risk safety. I wonder though, should this be an actor that runs on its own thread? Or should this be, what would you call it? Like just a class runs on the main thread. But I think for most of its work, it should have its own thread to run rather than on the main thread. But the work itself, I cannot guarantee what kind of thread it runs. The other thing is, I was wondering, like, why did I change it to actor? Why can't this just be a class? Let's try to answer that question. That should be an easy question to answer. Does it build for tests? It builds for tests. It didn't have to be an actor? Really? But what about all the errors that I was getting? How is that possible? I was pretty sure I was getting errors, and the reason why we switched to this being an actor was because it would just be much easier to deal with. There we go. This is where we had an error. I'm also curious about whether this should be a class or an actor. Let's see. Automatically serializes all access to its mutable state, runs every method on the actor's private single-threaded executor. You never need dispatch queue or locks to avoid data races. Any call must be marked with await. Yep. Now, here's the question. What if I yeah, it's not async anymore. That is an interesting discovery. I see. And question is, what if I say this is not sendable? I think the compiler would complain. What? How is that? Oh. You must be kidding me. I spent so much time looking into all of that and then thinking about, I might make this another branch rather than on the main branch, you know? Anything still says sendable? The value says sendable. Don't think it needs to. Oh yeah, the state needs the value to be an equitable value. What if I don't say this is equatable? Yep. State is not equitable, but I can still say So for now, I could say you have a... Actually, we can have an extension on the state where the value is equatable. Public extension on state. No, actually on... No, valid state controller where value is equatable. Can I build that? You can. Public static func. Yep, exactly that. If it is initial, if it is work in progress and invalid, yep, everything is true. Otherwise, it's false. So that way, int never conform to equitable, I believe. This would say equatable. Nice. Wait a minute. Oh, that's why they look weird. Okay, that's too big. We don't change that. Actually, quit. Split up. Can we split up more? This is all that's cached in. Basically, just said value doesn't have to be equatable and symbol, and the state is only equatable. Doesn't have to be equatable. Let's see. Okay. And then we want to stash the not indexed. Save the staged. Actually, let's just commit. Let's say this is a temp stash. Yep. Now, does it work? Now it has to be sendable. Okay, that's kind of easy. Oh, here's my thing. Give me 1 second. I'll be right there. Okie dokie, that was very silly of me. I forgot to turn off. I would be back soon. And now my food is here, so I'm gonna have my food and I'll be back after that. But let's fix this issue. We just need the state to be sendable, right? Non-sendable type. Cannot exit actor isolated state. So we just need to make the state sendable. Now the value needs to be sendable as well. That works. And let's see. So basically, what do we do here? Remove the requirement of value being, not being, being equatable. I think that's how you spell it. E-Q-U-A-T-A-B-L-E. Yep. Clever. And then if we pop, actor, we just want the class part. Does it compile? Does it work? It does not. That should work. This is so strange. I think I added sendable and then added actor because they said, hey, this storage thing, it doesn't work. The other thing is, if I don't use nimble, but if I use testing, RST, OPQRST, right? The linter is going to say, oh, I don't like this. This would be expect state to be, oh, actually. And if I fatal error, why doesn't it work? Oh, because it's, yep. And I think for the next few ones, it all look like that, but it should crash with the fatal error. Yay, it runs finally. And if we try that, hey, it works. If I say this is 41, it will say this fails. No, it doesn't say this fails. So testing still doesn't work. Why? Oh yeah. Doesn't matter. But if I change this to 41, I think that... Oh! Testing might only work with the hashtag testing. One more thing. Rather than testing, we need nimble. I'm silly. Should say... Oh, this also has an error. Should say valid state. I copied the text. Okay, let's see. I want to branch off. How do I branch off from here? I think it's just branch. Create a new branch? Switch to a specified branch, yeah. Optionally, a new branch could be created with either -c or -c. Yeah, okay, G switch -c. How should we name this branch? Class. Paste. Change valid blah 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 controller to a class. Go back to the original branch, and there's one thing I want to change, which is minor. Minor fix for the test string. Yep. All right, cool. I'll be having my lunch and I'll be back soon. I'm also very curious to explore down the route where it is a class, but let's have a read of what GPT has written down, and I'll be back after my lunch. Okie dokie, we're back online. All right, confirmed that, excuse me, that we are back online and the audio is back online as well. I was hoping, let's see. Wait a minute. I was hoping to have a check where, so the thing is, let's see, what's the thing? Nicholas, what is the thing? Yes, exactly. What is the thing? And where's my cursor? Okay, my cursor is over there, fine. I vaguely remember, let's see, if I run this again, I think this should work. I vaguely remember, I don't like this, Xcode having these sort of ghost errors. The thing is, I remember when we started, there was a reason. We did all the actor stuff, and we did all the sendable stuff, because we ran into an error, but now that error is gone. It is so strange. Excuse me. Somehow my voice is very bad. Let me duplicate a tab, and let's see. That one. Uh-huh. Okay. If I can, let me move the tab to a new window. I mean, it doesn't have to be that big. Right, over there we have everything sort of set up. And here we're writing our tests. And here we are trying to talk to ChatGPT, and we're writing out our first pass of the basic structure for our valid state controller. And it's somewhere around here. We were getting an error from Xcode saying, hey, I cannot run your code like this. I don't think you can hear the audio of this video, but that is a-okay. Yeah, it's right here. It says cannot convert the value to the thing that you want, and then things went wrong here. We probably spend 30 minutes to an hour trying to figure out why it is not doing the thing we want. Right there. That's the error. Come on, YouTube, load. If you can. No, still okay. I think it's over here, right? Sending storage risks causing data races. But now, obviously, it's not. It's not causing the data races anymore. So strange. And why is that? That's the thing I want to find out. It's Swift sendable and sendable metatype. Okay, that's fine. Anywho, let's put it back to the other screen. Keep my monitoring up, and let's see what is the next thing we want to figure out. So choosing between an actor and a plain old class, it comes to the trade-offs. Concurrent access. But here's the thing. We have this, let's have a look actually. We have this valid state controller. We only have done one, or actually two methods. It's load and update. We want to write a new spec as well. This would be valid state controller updating spec. Excuse me. And we'll probably do exactly the same setup. Actually, give me all that. But this time, it will be called valid state, controller updating spec. Nice. And we can say, excuse me, do we care about a storage? Saving, you just take that and then you do nothing. I think that's fine. Actually, this is a let. Excuse me about that. Validate. Do I care about validating? Not really. Validate, let's say. It's always itself. Because I think that's how validate works. Yep. Okay. Now it's the controller. Let's say we want to do the test, and then we want to say when updating with a valid value, we still want to say so it only takes 42 as a valid answer. Sure. So that, it will be, yep, I think that's, let's see, if I copy that, right? Because validate, yeah, so we can say, hey, we have work defined, we have validate defined, and right here, right now, we can say validate. What do you mean sending validate causes data risk? Data risks. Work is sendable. Okay, how about if we make this also sendable? And why does it take an extra comma? That's a great question. I didn't realize that. Let's see. Go back. Why can the line validate have the comma at the end? I don't think that's how you spell comma. Isn't it the last parameter? And this is Swift. Swift allows a trailing comma in any multiple line separate list, including function argument lists. Oh, this is new. Allow trailing comma in comma separate list. Interesting. I didn't know that. Oh, that's fascinating. Fascinating. And here, we can just say you use the same validate thingy. And if we run the test, that should be fine. Yep. And if I say this should be 41 or 421, it should say error. Yep. That's fine. The thing I don't understand is these ghost errors. They started to happen on Xcode 15, and they're still here in Xcode 16. Okay, before each, we have the controller being await.init work and storage and validate. Right. And then when we say, so this is a before each and controller.update with a value, which is valid because that's 42, it has a valid value. This is almost the same as the other one. Oh, it has an invalid state. Right, that's how we call it. Yes, yes. This is await. And if I say that is 41, it will tell me, no, it's 42. Right. And now, let's see. If I'm updating it with a invalid value, so this is 41, this test should fail. Yep. And now if I say this is invalid, it should succeed. Yep. All right. Cool. Cool. Right. We also want to figure out our test. Oh. Okay. These two are failing because. Come on, show me why you're failing. Aha. Let's address that, and let's go back. So both of those failed on main, but... Oh, right, yeah, that's fine. The class base does not have, let's see, add tests for valid state controller dot update value, and then we want format. Oh, that's clever. Yeah, clever. Yeah, that is also clever. Fine. I'll commit. Format code. I'm thinking about adopting the commit message. It's called get commit message convention. I think they have a thing. Quick summary, full spec. Yeah, just type. Fix, fit. It's like a feature. Breaking change. Build, chore, CI, docs style, refactor. Yeah. Conventional. So you have to use an npm package. Commit linked. Yep, basically that. How do we get this package? Okay, yep, contents, get started, website. Getting started. Install that, and then the configuration is picked up from those. Your configuration, documentation, API. How do I start to use it? Install and run. Yep. Okay. Check the main website. Oh, you guys do have shareable configs, easy setup. Let's see. Actually, I just want to get started. You just install that. And use that. Sure. And then the local one, oh, you just add it to your hook. Well, you use Husky, of course. I have used Husky before. And then that is your Husky commit message. What about CI? On GitHub Actions, you can validate the last commit messages or all commit messages inside a pull request. What if someone is not using pull request yet? Git version, node version, npm version, px, commit lint version, validate the current commits with the, validate PR commits with thing. Curious. We're not using pull requests yet. So let's not do that for now. Yeah, improving the approachability of data rate safety, for sure. Role identifiers. Oh, that is pretty cool. Function name with spaces. Oh, that is pretty helpful for 1, for 4, 500, 502. That is so neat. Ooh, we can access methods too, but be sure to actually invoke the method like this. If you don't, you get back an uninvoked function that you can call it on like this. Oh my god, that is silly. Oh, wow, that is kind of cool. Introduces opt-in support for flagging unsafe Swift code warnings unless specifically desired, which will make it significantly easier to audit unsafe code usage. It's not the same as crashing code. Things like false unwrap or reading index -1. Yep. Considered safe because that's expected behavior. Yeah. Code marked as art at unsafe must be called with a new unsafe keyword. Oh, I see. Backtrace API. Weaklet. Ooh. Means a property cannot be changed after creation, but it can still be destroyed. So you need to use it carefully. Oh yeah, that makes sense. Don't change it, but it can be gone. But that is weird. Why making it weak? Having a weak reference, you can destroy the original copy. I see. And then there's, oh, that makes sense. Transactional observation of values. Okay, creates a new observation structure that is created with a closure and provides an async sequence that emits new values whenever any observable data changes. It effectively gives us system power to monitor changes that SwiftUI gets just in a freeform way. Oh, a trivial observable class for a player with a score. And then we can ask to be notified that score changes using observations like this. Oh, I see. So we'll send out the updates whenever the score changes. Global actor isolated conformance resolves a small but important concurrency problem by making it possible to restrict a protocol conformance to a specific global actor. For example, now we can say this main actor restricted type conforms to quitable only when it's being used on the main thread like this. What? Why? Notice the use of @main actor quitable. If we had to conform without using on the protocol, would be free to run the equal method on any task, including the background, which is explicitly disallowed thanks to the whole type being marked by @main actor. As a result, our code could not build. Oh. Hello. You hungry? Yeah, you're always hungry. But you have finished. You have finished your breakfast and lunch. There's no more food I can give you. Starting tasks asynchronously from caller context. Introduce a new way to create tasks so that they start immediately if possible, rather than the existing behavior that only allowed tasks to be queued to run at the next opportunity. Hello. My cute cat. Task, print task, so immediate, print immediate task, print done. I see. Come here. Good girl. The new ability to create immediate tasks unlocks important new functionality. The coding an immediate task starts executing immediately if it is already on the target executor, perhaps providing important data that the UI controller is waiting for, but after that initial immediate response, the task can then use a wait like a regular task and potentially trigger suspension as normal. So everything in an immediate task runs straight away until the first suspension point is reached. Both task and task.immediate are unstructured tasks. However, task groups have also been upgraded to support immediate child tasks with add immediate task and add immediate task unless cancelled. Okay, that's a lot of reading, Nicholas. Yeah, I like reading stuff. Good girl. Now she's just lying on the floor right next to me, which I need to be mindful because her little paws are right next to the wheel of my chair. Okay, that's better. I don't want to run over you with the wheel because I am heavy, so the chair is also heavy. That's why I'm pushing you a little bit off the wheel. I know you like to. Well, I think the cat, they just like to hold on, well, touch on something with their foot. So they feel connected to you. Okay, let's see. Do you want to be picked up? I don't think so. Okay, let's not do that. Run non-isolated async function on the caller's actor by default. Yeah, okay. So we have the measurements, we want to fetch the latest, and then it's that. And then the data is just like, okay, we wait to get the data and then we return the decoded thing. This isn't isolated to any particular actor, so it can run its code anywhere. Next, we could use that with another struct called weather station, which will download all the readings and return their mean average. Yeah. Okay. This time, though, we will mark the structure as being isolated to the main actor. Isolated. Yeah. So we have one struct that is non-isolated and the another is isolated. And this demonstrates the change perfectly. Before Swift 6.2, the call to fetch latest will not run on the main actor, but from 6.2 and later it will. The old behavior caused some confusion, not least because measurements is a main actor isolated property in weather station, and the call takes place in the main actor isolated get average temperature method. The old behavior wasn't an accident. From Swift 5.7 specifically states that async functions that aren't isolated to a particular actor do not run on any actor's executor. This new behavior introduced by 461 means that the non-isolated async function will now run on the same actor as their caller unless you say otherwise. In the code above means will run on the main actor. If you do want the old behavior to return, to switch away from the caller's actor automatically, you will need to mark it with a new @concurrent attribute like this. Interesting. Now I am curious. With that in mind, shoot. I remember we just saw we're like printing out what thread we're running on. I think it is one of these. First look at how it's changing and what's new. Swiftly, I think it's task.current task. Not necessarily. Or what if we go to Google? No. Okay, that's not helpful. Let me see though. Can I bring up the history? Is it this one? Might be. Nope, not this one. Find it difficult. Sometimes you are trying to find out so many different things at the same time. And interesting. Where did my other window go? Okay, we're back. I thought I just read somewhere he said, I want to figure that out as well. Let's see. For example, if we go into here, and this is, all right, print task dot current. somewhere. Let's see. Let's put the extension on task. And then it's a var current task dot current. Task does not have current. Oh, it's thread, isn't it? There we go. And he was mentioning, let's say, can I just do thread.current? Cannot find thread in the scope. What do you mean? Thread is right there. It's in a thread. Cannot find thread in the scope. Oh, we probably need to import foundation, don't we? It's unavailable from asynchronous. If I say this is static. And, ooh, say, it's hard to figure out because right now I have a lot of tests. Hello? Okay, it's back. I'm hoping it's always the same state. But here is the thing though, right? If we go into here, we start it up and then we're not really doing too much. So every time it will be, let's see, print that. And this is init. Run that again. This is load. And this is update. Initializing, loading, updating. Initializing, loading, updating. Yeah, that's all on the same thread. Initialize, load, update. Sure, okay, so that's all on the same thread, and it's not the main thread. Unless, how do I turn it on? I don't think it told us how to do it. At least not here. Blah, blah, blah. Right. Nope. I thought somewhere they mentioned that, hey, you need to enable this flag in the settings. Ah, this one, exactly, yes. There we go, that's the feature flag. Oh, excuse me. If I can type feature flag. Ah, so the change is gated behind this feature flag. How do we enable this feature flag? I don't think you can. Upcoming feature flag. Vision, improving the approachability of data race safety. I would like someone to write a TLDR. This is just a lot to read. Anyway. Okay. So they always run, I think for actors, right? Well, they always run the calls on their own thread, which is great. What is this one? Isolated synchronous de-init. The ability to mark the initializer of actor-isolated classes as being isolated, which allows them to safely access data elsewhere in the class. For example, this class is isolated to the main actor and mark the initializer as being isolated so that it can safely call cleanup. Oh, I see. Why the de-initializer is not by default isolated? Non-sendable isolated state. Lifting restrictions imposed by 327. This is achieved by providing runtime support for hopping onto the relevant actor's executor before executing the de-init body. Really? On actors and initialization. Overly restrictive non-async initializers. An actor's executor serves as the arbiter for race-free access to the actor's stored properties, analogs to a lock. Huh. A task can access an actor's isolated state if it is running on the actor's executor. The process of gaining access to an executor can only be done asynchronously from a task, as blocking a thread to wait for access is against the ethos of Swift concurrency. This is why invoking a non-async method of an actor instance from outside of the actor's isolation domain requires an await to mark the possible suspension. The process of gaining access to an actor's executor will be referred to as hopping onto the executor throughout this proposal. non-async initializers and or deinitializer of an actor cannot hop to an actor's executor, which would protect its state from concurrent access by other tasks. Without performing a hop, a race between a new task and the code appearing in an init can happen. Clicker can't click. Self.count is 0. No actor hop happens because non-async init. Task await self.click. Self.click. This mutation races with the task. Can print 1 or 2. It imposes a restriction on what can be done with self in a non-async initializer, in particular having self escape in a closure capture or be passed implicitly in the method call to click triggers a warning that such use of self will be an error in Swift 6. Are overly broad because they would also reject initializers that are race-free, such as init OK, leveraging the actor isolation model, we know unknowns cannot touch the stored property. That's because blah 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 blah. Okay. I'm not gonna read all that. Restrictions imposed by that reduce the usefulness of explicit dneats in actors and global actor isolated types. Workaround for these limitations may involve creation of close-like methods or even manual reference counting if the API should be able to serve several clients. While this proposal introduces additional control over dneat execution semantics that are necessary in some situations, it also introduces a certain amount of non-determinism to the initializer execution. Because isolated dneats must potentially be enqueued and executed later rather than directly in line, this can cause subtle timing issues in resource reclamation. For example, APIs which require quick and predictable resource cleanup, such as scarce resource, such as e.g., file descriptors or connections, should not be managed using isolated initializers, as the strict exact timing of when the resource would be released is non-deterministic, which can lead to subtle timing and resource starvation issues. Instead, for types which require control over lifetime and cleanup, one should still prefer using with style APIs. Await, with resource, explicitly await resource.close or non-copyable, non-escapable types. I see. Maybe. Anywho. interesting. That's a lot of changes coming to Swift 6.2, which is the version that I'm using to write this SDK. Question. What does the package say? Why does it say 6.1 where it should be 6.2? Task naming. Introduce useful change to the way we create tasks and child tasks. Now we can give them names. It is helpful for debugging. That is pretty cool. Inline array. A fixed size array. An exact number of elements. Ooh, inline array 4 and string. That is so cool. Or you can let type inference figure out the usage. Okay. Oh, we can still read and write values at the specific index. Interesting. For example, we might want to match all prices inside a string by looking for any numbers that come after a dollar sign without matching the dollar sign itself. Obviously, yeah. So this proposal expands the regular expression support to include look-behind assertions, which allow us to check if a specific pattern appears immediately before the current position in the string without including it in the matched text. Oh. Oh. Oh? I see. Today, we didn't really work on anything. We're just reading a lot about the new features in Swift 6.2. There's so much more, I know. Ooh. Non-escapable types. Okay, anyway, I have done enough reading today. And let's see. Yeah, for my code, made it. What's the time now? It's like 2:51. I want to take another break, and I might come back to this and actually work on this a bit more. We haven't really done much working on this. We were being busy reading stuff. We did add tests for the update value part. So we now check if we're updating it with an invalid value, it's just invalid, and then we want to request a refresh. We are not checking that yet, because how do we know we are requesting a refresh? And requesting a refresh also depends on whether we are in the work in progress state. Anywho, let's take a break and I'll be back. Say, turn on BRB. And turning off my microphone. Okay, now we should be back live again. Yep, and I also can hear myself from my streaming monitor-ish thingy. Hi, Gunnar Coder. I'm sorry I missed your message during my break, but thank you for the message. Really lovely to see someone visiting the stream, even though I was away. Oops. All right. What is next? There's one thing I want to figure out with ChatGPT, which is, wait a minute, give me a sec. Okay. I was like thinking, what do I want to say? I was thinking that the screens, they were a little bit too tall. And there doesn't seem to be a way that I can bring all three down together. Oh, you know what we can do is do that and arrange. Yeah, I think that's how it works, right? I'm using virtual desktop, and supposedly virtual desktop should manage the arrangement of my monitors for me. All right, let me try something. I know there is a arrange monitor button. Oh, right, I didn't turn this on. Okay, yep, monitor's all good. All right, let's have another chat with ChatGPT. And we just want to say, so I am working on this valid state controller, and I want to be able, let's use the transcribe. I want the consumer of an API to be able to watch a stream of the state, but I'm not sure what API to pick. We could do a very basic completion handler updates method. We could do fancier ones like the observations added in Swift 6.2, or there might be some kind of stream from Combine that would allow that as well. I also know that there is a hashtag can import statement. Because I'm not sure where or how would my consumers to be using all this, I'm trying to decide between these different formats. I'm hoping you can give me some ideas. Let's see. So I'm working on this, blah, blah, blah. I want the consumer of the API, blah, 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 blah. Yep, that's basically what I said. Go. Here are a few different ways you might expose a live updating state stream from your controller with the pros and cons and some sample signatures. Public function, observe state, you give it a handler, and then I give you a cancelable. Every time the state changes, you call the handler new state. Okay. Return a lightweight token, a simple class you own that on the init unsubscribe so consumers can cancel. Very minimal, no extra framework, doesn't compose nicely, hard to chain or transform streams, or you can get them a delegate. Familiar patterns, singulars, and I don't like protocols, to be honest. I'd rather have completion handlers. If can import combine, public function, state publisher, any publisher, and it will just be a state and we'll have no errors. Yeah, posing combine, heavier footprint for sure. Get the full power of combine. Async sequence or via async stream. Wow, what is this? And where can I find async stream? It's purely in Swift. Plays well with Swift's currency. Can bridge into combine if you want. No built-in back pressure control, but you can buffer or drop manually. Uh-huh. Here is the thing. I think the easiest to adopt is like observe the state, and then you have this thing. But like ChatGPT said, it's not very composable. Oh, my cat. One second. I just found out that I locked my cat outside. Let me see. What can I do? Go over there, make your size smaller, and let's see. Where's my cat? Oh, okay. She's not trying to come in. I saw she was by the door. And this is the power of streaming on the Quest. I can basically move anywhere around my apartment, but still being able to talk to you guys and hearing my own feedback, even petting my cat while the stream is going on. On balcony, actually. She's on balcony. Good girl. I thought she was trying to come in. But nope. I think she's just like, Daddy, where are you? I am here. Come see me. Typical cats. Now, this is a design decision that we need to make. I was reading something about Swift 6.2 observations, right? Yeah, there we go. Observations. There we go. Transactional observations value. Yep. And we could make a trivial. Yeah, we can ask to be notified that score changes using. What about observable? Observable creates a new observation struct that is created with a closure, provides an async sequence. What is this? Transactional observation values. It says it is accepted, but I thought this is implemented already. Async sequence observability proposal. Numerous frameworks in the Darwin SDKs provide APIs for accessing an async sequence of values immediate from changes to a property of a given model type. For example, .kit provides tracking states, and group activities provides local participant states. These are much like any other APIs that provide async sequence. Give me 1 second. I'm looking for my drinking bottle? And I can't find it on my desk. It is on my dining table / coffee table. All right, got it. I need some more water. Clumsy. All right, I'm back. I am back. Observation. Blah, blah, blah. Observation was built to let developers avoid the complexity inherent when making sure the UI is updated upon value changes for developers using SwiftUI and the observable macro to mark their types. This principle is already realized. Directly using values over time should mirror this ease of use, providing the same level of power and flexibility. That model of tracking changes by a graph allows for perhaps the most compelling part of observation. It can track changes by utilizing naturally written Swift code that is written just like the logic of other plain functions. In practice, that means that any solution will also follow that same concept. A closure initialized observations type. Okay. This is observable, and then creating an observations is straightforward. Okay. Yields a value every time the compose name property is updated. However, if the example was more complex and the person type in the previous example had a var pet question pet, yeah, sure, which was also observable, then the closure can be written with a more complex expression. Let greetings equals observations, and then if let, okay, pet equals person.pet, then we return the person.name and pet.name. Otherwise, we just say, hey, person.name. Interesting. Okay, there are a few behaviors. Okay, that's like the prerequisites. Tiering is where a value is expected to be assigned as a singular transaction operation can potentially be observed in an intermediate and inconsistent state. Uh-huh. Oh, Swift has a mechanism expressing the grouping of changes together called isolation. When an actor or an isolated type is modified, that is expected to be in a consistent state at the next suspension point. This means that if we can utilize the isolation that is safe for the type, then the suspensions on that isolation should result in safe and non-torn values. This means that the implementation must be transactional upon that suspension, starting the transaction on the first trigger of a leading edge and then completing the transaction on the next suspension of that isolation. Oh god, what did you do? Creating the person, well said the name, did set the name, well said the last name. The transaction is still dirty, did set the last name. The next transaction, the next suspension for the name property will be valid. Huh. Very interesting implementation details straight up. Today, it's mostly just like learning stream. We're learning a lot of new Swift, especially 6.2. Two things. One is Swift. I have searched that. Observations, but not 6.2, but just observations. So this is only available on 17, 17, 17, 14, 17, 1, and 10. So basically the latest. Observation provides a robust, type-safe, and performant implementation of the observer design pattern in Swift. To declare a type as observable, wait. I thought this is available earlier, no? Only on 17 plus, really. What about async sequence? Ooh, actually, this is pretty asynchronous sequential iterative access to its elements. How do I create an async sequence stream? Make async iterator. Why doesn't it provide any kind of like sample code? There we go, swiftly coming clutch. Okay, so you can create an async sequence. And then you can create an async iterator, which follows that protocol. That seems to be a very what would you call it? Very detailed way to create your own async sequence. Is there no way we could just okay? There's no way. Hey, Tita la, welcome. Nice to see you here. Is there no way we could just create? I guess that's why there is observation. So if I say, I don't need that anymore. Get rid of that. Observable. Oh, do I need to import foundation? Wait. Sure. Observable. It's a macro. Does that build? Observable cannot be applied to actor type valid state controller from macro observable. Why? It's only available on macOS 14 or newer. Migrating from the observable object protocol to the observable macro. Update your existing app to leverage benefits of observation in Swift. That requires iOS 17 and macOS 14 and plus. What is the macro? So before you're importing SwiftUI, but after you're still importing SwiftUI and you're making the thing observable. It generates source code at compile time to add observation support to the type. Okay, tell me about that. This macro adds observation support to a custom type and conforms the type to observable protocol. For example, the following code applies the observable macro to the type car, making it observable. Okay. Combine would be pretty helpful. Okay, I don't want to add that for now. Did I change anything? Okay, that's a minor change. State work requesting the refresh. Update the state based on whether the value is valid. If the state, it will request a refresh. This one is a private method, so it doesn't have a doc string, but we can say try to load a valid state from storage. If no valid state is to be found, it will request a refresh. Still, I prefer the doc string, even though it's a private method. Requesting a refresh. Guard. We're trying to guard that case dot work in progress. Oh, actually, if case dot work in progress is the state, then we return because it is unexpected else. Oh, yep, that is extra. Request a refresh of state if we if no work, if not work in progress. This one calls the false refresh, the cancel refresh. Okay, leave it there, but false refresh, we want a private function called just refresh. This one calls refresh. This one also calls refresh. Force a refresh without checking the work in progress state. What does the refresh do? It basically does await work, and then async call in a function that does not support concurrency. Yep, async. What is the type signature of work? Async. Async. But everything here is async. Wait a minute. If I don't say async, but I just say await. Yeah, make it asynchronous. Make this asynchronous. This is await. This is also asynchronous, isn't it? You're going to say await. If I can type await. And this is async await. The call can throw. Do I want it to be throwing? The one more thing is, rather than calling this error, what about we call this failure? So wait for that one for now. Actually, I don't know whether it's timed out or not because I have no idea whether it's a timed out error. Okie dokie. Does that work? I think it does. Okay, let's say we try. It's not being handled. It will be do, try, catch. A value is that. Catching, and then the state would be dot invalid to do. Does that work? That works. And here's the thing. If the refresh did the refresh thingy, do we still check whether it's valid? And if it is not valid, okay, here's a question. To do. If the value is not valid, do we keep retrying? And the other thing is, also, what is the retry strategy? We would say update value, and this is also await. Does that work? That does work. And the test fails. Why? which part of the test that does not like my new, oh. Expected to get invalid, but it got 42. Oh, right. I now know why, because we said work would give you 42. When there's nothing in the storage, when starting the controller, it has an invalid state. Oof. Oof. Yeah, now it calls the work. Which is good. So we do need to rethink about, it's either that we rewrite the tests or we rethink about the behavior of the valid state controller. Invalid reason. Invalidated, cancelled. This would be invalidated, cancelled, and not cached. Not found. Cache not found. Excuse me. Drinking a bit more water. Let's see. Let's not add that for now. Seems a bit more complicated, and we have a few more different things to solve. Initial loading. Well, at least for the state, right? It should go through initial, invalid, and then go on to like requesting a refresh, and it gets the new state. And that state is a valid 42, but in between there's invalid. If we use combine, we could capture that. So now I'm just thinking, what should we do? Let me take a short break and I'll be right back. Think about this. Yeah, let me think about this. BRB. Hello, hello, hello. We should be back. All right, that is confirmation. All right, we are back online. Somehow my stomach is complaining about things. This has been a 4.5 stream, well, including quite a few breaks, for sure. Otherwise, how could you survive? And I'm hearing a little bit of blips. Yep. Likely either Quest or my Mac is not happy with the connections. Shall I try again? I'm gonna do this just like this for now. Let's see, what do we want to do? We want to do, okay, let's say we use combine. Well, we provide a combine stream for our consumers and also help with our testing. Would that impact any consumers who are not using combine? I don't think so, but I also don't want to like lead ChatGPT anyway. If you get with a if can import combine, you're not forcing every consumer to import the module. They won't even see those APIs. Ooh, that's cool. Anyway, I need to run again because my stomach complains, and I'll be back later. Okie dokie. Sorry about that. It has been a while. My stomach seriously disagree with whatever I just had. Without going into too much detail, that is exactly what happened. And are you hearing that? The blips? Let me double check on my phone. Let me see. Give me Twitch. Are you hearing that? The blips? Oh yeah, you're definitely hearing the blips. Even I am hearing the blips. Give me 1 second. Testing. Hey, the blip is gone. Well, it was gone. And actually, I think this microphone might have a better quality than the one that I was just using. Interesting. But I still hear the blips. Let me restart the softwares. BRB. Technical difficulties. Okay, I am back. Hey, now the sound is pretty clean. Well, I might have spoken too soon, but I think right now it is pretty clean. And I'm not sure whether it's because this one has a better speaker or whether it actually has a better microphone, but this time it does sound pretty good. Let me see. If I turn on my mobile phone, turn on the volume, how does it sound? Hello? Why can't I hear myself on my stream, on my own phone? Supposedly I should be able to hear myself. Yep. Hey, sounds pretty nice. Awesome. Okay, all good. Oof. Technical difficulties of the human body solved. Technical difficulties of the quest solved. The cat is not here, which is great. Let's get back to this. No added runtime cost. State publisher. Okay. Let's see. I want to give it that. So this is my controller code. If I want to update, have a stream of state, what's the most sensible way to add it? Okay, zero dependency ways to piggyback the concurrency and exposure state as. Hey, that's not what we just talked about. Power function, they changed the new state. Oh, interesting. Internal continuation and optionally a combined subject. Is user ID async stream state dot continuation. And I see. If I import combined subject dot send new state pass through object. Replace all the direct state equals new actor with calls to change to, okay. Or update state. Async stream continuation dot yield state. Let ID equals UUID. Continuations ID equals continuation. Continuation dot on termination, remove that. What? State append the subject starting by Sending the current state, then subscribe to the subject. Okay, forget about async string. Just demonstrate with combine. So if we can import combine, and we have that the combine publisher is the subject of remove duplicates dot erase to publisher. Actually, I don't want to remove duplicates. Public API for consumers who want a combined stream. Current value subject holds the current state and replace it to the new subscribers. Swift. Let's have a look. Current value subject. A subject that wraps a single value and publishes a new element whenever the value changes. Unlike the pass-through subject, maintains a buffer of the most recently published element. You can subscribe to it as well using combine for your app's asynchronous code. Replace the completion handler closures with future. Using output types to represent the future's parameter. Replace repeatedly invoke closures with subject. I like the easiness of having a closure. This is really heavy lifting. Like, oh, you get a pass-through subject, and then you erase that to any publisher. Now you can just do, hey, unless there's an actual streams of data, that would make sense. I think current value subject makes sense. Even the state doesn't have to be a state. Okay. Private let subject. Actually, we need that. But for us, definitely equals, well, actually, current value subject. No, subject equals state subject equals state never dot initial. Isn't it called current value subject? Oh, right. I need to do one more thing. Say not that, definitely, but this part, because we don't have combine yet. The state would just become the state subject dot value. Like that. Cool. Very cool. And where do we go from here? The state is already using initial, that's fine. And we are not saying state is invalid, but then rather than saying that, we say subject dot value is invalid. Sure. We can also send down like errors with the what is exactly a current value subject? It is a subject. What is a subject? It is publisher and a subject. Subject is a publisher that exposes a method for outside callers to publish elements. A subject is a publisher that you can use to inject values into a string by calling its send method. What if I assign values to the current value subject? Publish as a new element whenever it changes. Okay. So basically, we want to do that. We want a private function called update state. Update state dot invalid. Yep. Update state dot invalid, and then update state valid and is state for sure. Then update state dot invalid. Yep. All right, let's see. If the value is no valid, do we keep retrying? So what is the retry strategy? I have no idea, but that's not something we want to solve right now. We do want to expose. Okay. Any publisher subject. All right, we do need to wrap that into that. Right, then I don't think there's point wrapping this in if combine because everything will be powered by combine, at least internally. Since I use combine. But they don't have to, they can just use that. Public, private, 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 that's the dependencies. Okay. With the code looking like this, is there a way to what if for testing I want to subscribe as soon as possible to not miss any changes in the state, because we start the object by loading things, which means the states would start changing. You run into the classic hot publisher in async init problem. By the time your async initializer hands you an instance, the load state dance already happened. Make your initializer purely synchronous. Introduce an explicit start or load initial state method, which your production code can call immediately, and your tests can defer until after they have hooked up. Okay. Okay, let's do what they said exactly. This will be public function start. And here we say wait load state. And we'll kill that. We are happy to make this an async call. It doesn't throw. I'm happy to put this update method up here because everything sort of acts as that. We could also put it like down at bottom, but this is really simple, so I don't mind. We load the state, we can call update, we can call request refresh. The refresh basic does that. If the value is not valid. Question. Should we assume the value is always valid? Because if it is not, one, we have to do checks after the work is done. Two, if it is not, we need to, should we retry? What is the retry policy? Immediate, static, custom-ish. Or we can get like a retry controller thingy. It gets a bit more complicated, but I think right now it builds. But the tests, they're broken. Tests will be like, no, I can't do this, I can't do that. Wait. Yeah, the tests wouldn't be too happy. Let's see, the updating one. We got the valid 42. Wait, this is invalid one. Oh, right. Because they would try again. Okay, one thing at a time. And then we can say await controller.start. Yeah, we need to do that for almost everything. Question is, when starting the controller, it has an valid state? Not anymore. It only said initial. Yeah. A few different things need to be changed, but let's check the diff that we have right now. For now, it just have a very immediate retry philosophy. And the updating spec is also a bit wonky now. When updating it with a valid value, it will have a valid state. But if we're updating with an invalid value, then okay. We can say subscription is that, sync is that, and then seeing is that. Okay, here we can just say, hey, sing, wait, would it be state? Oh, well, actually, controller.state, an array of states. Before each thing would be, actually, after each thing would be new. Before each thing would be a list sub equals controller dot right. I don't think we have a thing that expose the things yet. Yeah. We also need a public method. Public var state publisher. Any publisher state subject dot erase this state. Yep. That works. And then the thing is that dot state publisher dot sync thing dot append dot 0. Yep, just like that, I think. What what if we change this to a function? Function. It's still a extra isolated, so it has to add a wait. Same, not that much different. Can I do that? Any publisher is not sendable, so it cannot exit actor isolated context. Interesting. When I'm trying to use the state publisher in test, got this error, which makes sense. But wouldn't that mean we can try that? We can definitely try that. Okay, it's a public let state publisher. It's a pair, state publisher and state subject. And we want to say self.state publisher equals dot erase to any publisher that builds. Does that work? It is any publisher. And why is not any publisher a sendable? Swift any publisher sendable? Yeah, are not sendable, so we get warnings if we pass cross actor boundaries, since it can't update any data, so accessing from different threads should be fine. Subject is that, publisher is that, not sendable is that, and then setting the not sendable. Combine won't ever be safe. with Swift concurrency. What do you want to do about that? The problem is warnings where conceptually there shouldn't be some. No warnings where conceptually there should be. Shoot. There is no clear-cut answer to your problem. I believe strongly that the long-term answer is to replace combine with async-sequence, but in the short term, you probably have a mountain of combined code you need to live with, and even with minimal concurrency checking in Swift 6, Swift 5 language mode, you're probably getting warnings that aren't helping you. I really think it's up to you how to deal with it. Pre-concurrency import, if it works for you, adding retroactive extendable conformances, even though they're not strictly true, because you still have to use the types as if they are, leaving the warnings as signposts to dangerous codes. Shit. Sounds nice in theory. There are still many unresolved problems. Doesn't allow multiple observers. Yep. Lack of flat map latest. Lack of the equivalent of store in cancellables. Yep. Sad. Why are these things so hard? Just why? Not the best idea. Might be a bad idea, but what if I say this is a class? Does it build? Hey, it built successfully. Wait. Testing also built successfully. The test failed, that's fine. But it hurts my head less. Fun things with actor. With Swift 6 concurrency safety, what does it mean for a method to have a async keyword? A synchronous non-isolated method on an actor still runs on the caller's actor. No hops, no sendable check. An async non-isolated method always hop off the actor when you await it. So its argument results must be sendable. Why is this so much headache to work with? Class instance async method versus actor instance async method. Difference? When you mark a method as async class versus an actor, runtime treat them quite differently. Class async, a plain Swift class has no built-in executor or isolation domain, no automatic queuing. When you do, you may suspend and resume on any thread, but you're not guaranteed to hop onto a special data loader queue. No protected states. Yeah. If fetch touches self-stored properties, you must still manually synchronize to avoid race conditions. Actor come with a dedicated executor and implicit isolation of their mutable state. Now, here's the thing. What if I go back to the test that I was doing? Sub doing that, and then await controller, they update it with an invalid state. And it had an invalid state. So we would expect, right, scene to be, and if I run that test, it will tell me it's wrong. Not for that reason, but because I didn't say you also have initialization. Got valid 42, invalid, and valid 42. Why? Initial invalid valid 42, invalid valid 42. Interesting. Why so many? When they start, wait a minute, try this again. When they start, they get a 42, which means it's valid. It's initial. And we want to wait for this to finish, right? Before. True. Let's see. How can I wait for all async to finish before running the expect line? Hmm. Async await quick nimble. Does not compile. It does compile. Async testing with quick and nimble. Yeah. Async await. Oh, this is someone wrote a snippet. Yeah, before it looks like that. That's not what I'm hoping to get. What if I say await? What does this do? There's only initial, but actually we were hoping to get a bunch more stuff. But strangely, this one got valid 42, invalid, and then valid 42. Does it make sense? Doesn't quite. There is a bit of a racing conditions going on here. If we were not using async work, why is this so hard to work with? I think I really need like a book on the async await things. If you're using async await, how do you even test things? Anyway, I think the stream would be ending here. It's about 5 hours and 20 minutes stream. And there was a lot of reading, and apparently there is still a lot more reading to do regarding whatever we're trying to build here. I thought this would be simple. Apparently not. I think with async await, maybe the best way to test things is just like with this one, right? Expect state to eventually, wait, not here, but here. Rather than that, expect scene dot to eventually equal dot initial dot valid 42, and then it's invalid again, and then it's dot valid again. Oh, excuse me. And instance method is available from asynchronous. The sync variant does not work in async contexts. Use the async variant to eventually async. Okay. There we go. Concurrency async support. Await, expect, await to equal. To avoid compiler error, blah, 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 with async expressions that does not, however, the expect async function is provided, which does support. Similarly, if you were ever in a forced to come to produce a sync expectation, oh god. Async matches, all pass satisfies all of. So if concurrency support is different than the two eventually blah blah blah, works by continuing polling as described here. Support is about waiting for an expression to finish. What is an async matcher? And why there isn't much of like a code sample. Anywho, I think it's time to finish this stream and take a break from all this. Hopefully you have enjoyed seeing me struggling through all this, and I will see you next time.